Okay, we're just going to give a bit of an introduction and kind of look at the initial type, or I suppose category of integrals. So integration is very, very closely related to differentiation. Okay, so closely, I suppose, that we can consider it nearly anti-differentiation. We're essentially following the same steps but in the opposite direction, or undoing the steps that would have been done in differentiation. So it's the reverse of differentiation. An antiderivative, I suppose, is quite a general term for a potential integral of a function. So in theory, I suppose, if I have a particular function, then antiderivatives could be any function that would differentiate to that function. So antiderivatives of 2x could be x squared plus 2, x squared plus 4, x squared plus 7, because as we know from our differentiation rules, a constant term differentiates to 0, because it has a 0 rate of change because it has no variable. So any of those functions could differentiate to 2x. So any of them could be an antiderivative, or is considered an antiderivative. There are an infinite number of antiderivatives for any function, as we can see, and we usually want to find what we would call a general antiderivative, which is called the indefinite integral. Okay? And we'll look at, I suppose, obviously we'll be looking then at what we call a definite integral, but the indefinite integral is indefinite because of that idea of that constant term. Because with differentiation, any constant term, the derivative of a constant term is 0. So when we're integrating or going backwards, there's always potential that there was a constant term there that we don't know about, or that we indeed don't know the value of, unless we have more information. Okay, so therefore this antiderivative that we're creating here, we can never be 100% sure that it is the correct or the full integral for the function that we have. So we kind of work with this indefinite integral for the time being. Okay, and what that really means is using this plus c. Okay, that you can see. So we use what we call the constant of integration plus c, and that just represents the possible constant terms I could have in the function. So when we're integrating without bounds, we have to include that constant of integration to account for any possible constant terms. So the idea, I suppose, if I have the derivative as a function, then the integral of the derivative is f of x plus c. Same idea if we use dy dx. The general rule that we have for integration is the complete opposite of differentiation. We add 1 to the power and divide by the new power. So for differentiation, we multiplied and then we multiplied by the power and then reduced to the power. Here we do the opposite, but also in the opposite order as well. We're completely undoing it. So add 1 to the power, divide by the new power. In terms of properties of integration, the integral of 1 over x gives me ln of x. The integral of a constant will just go to ax and then our plus c as well. If I'm integrating the sum or difference of two functions, then I can split that integral out in this way, keeping the sum or the difference between the two of them. And integrating any constant term times a function can be converted to that constant term times the integral of the function. So that constant term can nearly be factored out, okay, if it's a constant factor. Main things to note as well, dx just refers to the fact that our integral is with respect to x. So think of how we had dy dx to just show that the derivative here is the derivative with respect to x. We have similar to our integration. You should include that dx because otherwise it's very, I suppose it's not wholly clear exactly what integral or what variable we're integrating with respect to. Generally, you'll only have one variable, but we include it, I suppose, because that's kind of convention. It has to be included. Otherwise, it kind of means nothing. We can only integrate expressions of the form ax to the power of n. Okay, so that's particularly with our course here. We can only integrate kind of standard powers. We don't have any product rule, we don't have any quotient rule that we need to worry about in terms of leaving cert higher level. So to that, I suppose to that end, we're just focusing on basic powers, x to the power of something. That might mean simplifying terms using some different rules, whether factorizing or something like that. And we can verify by differentiating. I suppose that's always important as well. We have that idea, we always have that tool where we can differentiate to verify our answer. And I suppose then we'll be able to do the reverse as well now moving forward, where we can integrate to verify our derivative answers. So integrate the following functions. So 3x squared plus 2x minus 1. So to integrate 3x squared, we raise the power by 1, so it becomes 3x cubed, and then we divide by the new power, which is 3. Same with 2x squared, we raise the power to 2 and divide by 2. 1 goes to 1x, and we divide by the new power of 1. Okay, and we also need our plus c. So reducing that down, x cubed plus x squared minus x plus c. Okay, and the plus c there, that constant of integration. Looking at the next one, x square root of x is x to the power of a half times x plus 6. This, if I was, say, differentiating, for example, would be a product rule. So I don't have the same for integration, so there must be a way to reduce it down. So in this case, multiplying the bracket out is going to be the best and most surefire way of doing that. So that's going to give me, let me see, raise the power by 1, so x to the power of 5 over 2, and then divided by 5 over 2, plus 6x to the power of 3 over 2, divided by 3 over 2, plus c, and we get 2x to the power of 5 over 2, divided by 5, plus 12 x to the power of 3 over 2 divided by 3, and if we can reduce it down we might as well. So 2x to the power of 5 and 4x to the power of 3 over 2, and again my plus c, my constant of integration here. Same with the next one again, this would require a quotient rule. I don't have a quotient rule, so we need to reduce it down in some way. So we can go to 4x minus 2 minus 5 over x squared. Again, I still could reduce that a little bit more, minus 5x to the power of minus 2 dx. So that's going to give me 4x squared over 2 minus 2x minus 5x raised the power by 1, that makes it minus 1. So add 1 to the power, that makes it minus 1. Divided by the new power, which is minus 1. So 2x squared minus 2x plus 5 over x plus c. Okay. I suppose the key thing that we've been looking at is that constant of integration, and we may be given more information in the question that could help us find that constant of integration. So a good example is the one given here. We might be told that there's a point on the curve that we can use. So they're telling us find f of x given this derivative and knowing that the curve passes through the point 2,7. So if I was to integrate this function here, this 4x cubed minus 6x squared plus 8x minus 2. So if I integrate this function, I get 4x to the power of 4 over 4 minus 6x cubed over 3 plus 8x squared over 2 minus 2x plus c. So x to the power of 4 minus 2x cubed plus 4x squared minus 2x plus c. And we know that the point 2,7 is on this function here, so I can fill in the value of 2 for x, and note the answer should be 7. So that's going to give me, see, 16 minus 16 plus 16, a lot of 16s, minus 4 plus c equals 7, which means that c equals minus 5. Okay, so f of x is x to the power of 4 minus 2x cubed plus 4x squared minus 2x minus 5. Okay, so you can see now that c no longer unknown. Okay, that constant of integration now a known value for us, given that we had a little bit more information about the function. So up to this point, this is our antiderivative, our indefinite integral. It could be any possible function here, and once we have more information, we can find the specific function that the question requires. So into some exam questions here, we just have a few really in terms of the indefinite and the antiderivatives here. So g of x is 2x squared plus 5x plus 6. Find the integral. So the integral here of 2x squared plus 5x plus 6 dx. So integrating that, raise the power, divide by the new power, raise the power to 2, divide by 2, raise the power, and include that plus c also. And that's the best we can do. We have no further information, at least in this part of the question. It may have gone on to give more information. Write down 3 distinct antiderivatives. So let's integrate the function first of all using that constant of integration. So we're finding that general antiderivative. So x to the power of 4 over 4 minus 3x cubed over 3 plus 3x squared plus c. So that's x to the power of 4 over 4 minus x cubed plus 3x squared plus c. So possible antiderivatives that we could have here would be x to the power of 4 minus x cubed plus 3x squared. We could do plus 7, we could do plus 8, we could do minus 6. We could put in any number there. So any number replacing c would be absolutely perfect there, because when it's differentiated, that would reduce to 0 then. That would kind of differentiate to 0 and be gone regardless. Okay, so that idea that an antiderivative is a general term, or any possible function that could differentiate to this, or for which this would be a derivative. And then that idea of that indefinite integral, using that plus c as like a general antiderivative here. So what is meant by the indefinite integral of a function? It's the integral or antiderivative which includes the constant of integration c. Which includes the constant of integration plus c. So it's indefinite integral, which includes the constant of integration plus c. Okay, so we're unsure of that idea. Right, then the indefinite integral, so that was the one that I had at the very beginning there, x to the power 4 over 4 minus x cubed plus 3x squared, and then my plus c at the end here. So that idea of that difference between an antiderivative, which is where that c would be replaced by a number, and the indefinite integral, which maintains that c there. Okay, next one, find this integral. Again, just making sure that maybe everything is written in terms of a power here before we try and do the integral. X to the power of 3, so x to the power of 4 over 4, plus x to the power of 3 over 2 divided by 3 over 2, and then my plus c as well. And then it's just a little bit of algebra, kind of what we've talked about in some other parts here. So that idea of x to the power something over 3 over 2, if you're unsure, you could put it into your calculator, 1 over 3 over 2. To get that idea of 2 over 3. Doesn't want to give it to me here. 2 over 3. And if you were unsure of maybe why the 2 is going to the top there. Okay, so that's my definite integral, or my indefinite integral for that function there. The best I can do, I have no more information. Finally, the graph of f of x cuts the x-axis at 3 points A, B, and C. Given that f dash x is given as follows, show that this is the original function. Okay, so let's integrate the derivative here, because that should give me back to the original function. So we're integrating 6x squared minus 54x plus 109, which gives me 6x cubed over 3 minus 54x squared over 2 plus 109x plus c. So that's, let me see, 2x cubed minus 27x squared plus 109x plus c. We know that the point A, 2, 0 is on the function, so we can use that to our advantage. So f of 2 should be 0. And f of 2 is 2 times 2 cubed minus 27 times 2 squared plus 109 times 2 plus c, and it should be 0. So let's see, that's going to give me 16. 27 times 4 is 108. And then 109 times 2 is 218 plus c. So c is, let me see, 218 minus 108 plus 16, 125. Let me see, have I filled in something? 108, excuse me, not 109. 126. So 126 plus c equals 0, so c equals minus 126. And therefore we've shown that our function is 2x cubed minus 27x squared plus 109x minus 126. Okay, so again, using the information in the question to help us find the value of that constant of integration. That really is the key thing for any questions regarding indefinite integrals. So the main thing with an indefinite integral, you need to make sure you've included that constant of integration c, and then that if there is any information in the question, that you use that to find out its value. Okay, ideally, we wouldn't leave it in the question. Okay, we would try and find a value for it, but if it's not possible, then it's not possible. Okay, and it's kind of as straightforward as that. But that idea, indefinite integral, okay, and following your usual rules, or the rules we've introduced there for integration, raise the power and divide by the new power, okay, just the opposite of what we would do for differentiation, and that idea that we can always use differentiation as a check for our integrals.